webinar today. And my name is Thomas Schmidt from HUAFENG, and I would start that seminar, and then during the process we will change the speaker from time to time that you can get to know everybody of us. Yeah, the big question in our mind was really how to create high performance sport shoes in a more circular way. This is the key question driving us forward, and we would like to share today our experience from this exercise, experience in a joint project between HUAFENG, between Cyclone and Covestro. Basically, what we have done here, we applied 3 key technologies to enable this solution we want to introduce today to you. The part 1 is basically a new type of resin, a polyurethane resin, water-based, made by Covestro, and this resin is essential ingredient for our haptic coating ink, which will be introduced later to you. And this is a partly bio-based polyurethane resin. And second part is our haptic ink, the haptic ink formulation based on this Covestro resin. And with this 3D printing ink, we can decorate shoes, and mainly mainly for visual purpose, but also for functional addition of special functions, special areas of footwear. And the third very important part of this project was Cyclone, the Cyclone yarn. These are recycled polyester yarns, contributing significantly for the CO2 savings. And overall, we will show you later, we achieved quite a significant CO2, reduced CO2 footprint. Yeah, and in the next slide, I hand over to Bonnie, who will introduce the contents of this seminar to you.
Hello, everyone. I'm Bonnie, Marketing Deputy Director of Cyclone. Here are the contents we present for you. HUAFENG, Cyclone, and Covestro companies introduction and footwear industry trend sharing. And part 1 is partly bio-based PU Covestro in-skin introduction. Part 2, 3D fabric coating, HUAFENG haptic introduction. Part 3, recycled PET, Cyclone introduction. And our value chain collaboration delivers drop-in solution and lower carbon footprint sharing. Next, please.
Also from my side, a warm welcome to you all. Let me shortly introduce you to our today's presenter. That is Bonnie. She is a marketing deputy director at Cyclone. Bonnie had 14 years experience in sporting goods and textile industry, 5 years of brand sustainability experience, and is committed to contribute to our social environmental protection. Thomas Schmidt, who started already, he's the director of innovation at HUAFENG. Thomas' background is chemistry and material science. He has more than 30 years experience in scientific research and industrial innovation. His career developed in various international assignments in sport industry, coating industry, and now in textile industry as well. His work on this, a little bit too quick, Thomas. Sorry.
Sorry.
His work on the 3D haptic textile coating was acknowledged in several national and international awards. My name is Thomas Beck. I'm working already 5 years at Covestro in Leverkusen, and I'm the lab manager of the textile coating laboratory, and I do market development and technical service in the EMLA region.
All right, and now get started with a company introduction and also about some trends on footwear industry. First, I would like to introduce HUAFENG to you. HUAFENG is a large-scale textile manufacturer, a Chinese company, and we are based in Putian, basically opposite of Taiwan on the coast in south of China. And we have a very vertical textile supply chain. We basically start from yarn manufacturing or yarn texturizing, and basically buy the POY yarn and texturize it to make a DTY. Then we have all different kinds of knitting technologies available: warp knitting, circular knitting, and also a big factory for weaving technologies. And after fabric creating, we also have a large-scale modern dyeing factory with a very modern wastewater treatment system and low water ratio dyeing tanks. So also a very modern semi-automated dyeing factory. And our core products are basically the fabrics, which are sold usually to footwear or garment factories. And our core markets are the sport industry, but we also supply to other industries. Today, we have about 13,000 employees, and we are mainly manufacturing in China and in Vietnam. But we have a global customer support network. What you can see on the left side, we are today in every continent. We have sales offices, and especially important maybe for you to know, in US we have an office in Portland, and in Germany, in Europe, we have an office in Herzogenaurach. Yeah, and beside of this fabric business, in the recent years, we have developed haptic 3D coatings, and this will be introduced in more detail later on. But the key of this haptic technology is that we functionally decorate the footwear uppers, so we and cut them to size and then deliver ready to assemble footwear components to the shoe industry, to the shoe factories. And this really revolutionizes the supply chain of footwear manufacturing. Yeah, then I hand over to Bonnie again.
Cyclone is a vertical green fiber manufacturer features in sustainability, innovation, and technology. It's with the large capacity of 240,000 tons per year recycled PET. Have you ever thought of the waste bottle can be recycled and reused onto the brand new textile? Cyclone innovative physical recycling technology with the bottles as feedstock. To assure the consistent quality and short lead time, Cyclone has own bottle collection system in China. The other innovative product is the colorless recycling yarns for the piece dyeing. We also call it dot dye recycled yarn, which is with the maximum sustainability and performance. I will introduce more in the further pages. Next, Thomas Speak will introduce Covestro.
Thanks. Covestro is a worldwide active manufacturer of polymers for a wide range of industries. Covestro had two major divisions: solution and specialties and performance materials. In 2020, we had 10.7 billion euros in sales, and we have more than 16,500 employees. We had 33 production sites globally and are close to markets, customers, suppliers, and partners. We are highly innovative with more than 1,200 employees in R&D and 80 years of ideas and inventions. With a very dedicated global textile coating team, Covestro have been actively serving textile industry for many years. Includes automotive, interiors, sports, outdoors, furnitures, technical textiles, electronics, and fashion industries. Our vision at Covestro is to become fully circular by 2050. And now we are on the way towards that objective, the development of more partly bio-based material, CO2-based materials, increase the usage of solar and wind power, and also recycle and off-life PC and TPU materials, and use them again in the new products. Circular economy is the key to resource conservation, climate and environmental protection, and plastics are a driving force for implementing circular economy. We want to become fully circular. We want to contribute to market circular economy, the global guiding principle, and anchor this principle across the company.
Yeah, and you're probably fully aware already that the world is in a race to net carbon zero performance. And this is also our ambition here to contribute to that race to zero. The world is teaming up to tackle climate change, and there is, for example, a special report from IPCC on the impacts of global warming at 1.5 degrees centigrade. And as you also probably are fully aware, that the Paris Agreement, where many nations agreed to limit the global warming to well below 2 degrees, preferable to 1.5 degrees Celsius. The net zero emission race is already joined by 137 countries who have committed to carbon neutrality on different timelines, but basically all of them are committed, and the world is really joining together to make a change. Bonnie will talk about the footwear market now.
Yep. 20 billion pairs of shoes, that is the amount of the shoes which was produced in 2020. The footwear industry has the strong willingness to produce shoes with lower carbon footprint. And many shoe manufacturers and brands already make their statements. Some of these statements you can find on this slide. Some are companies which declare a net zero by 2050 or a reduction of up to 60% of the carbon footprint by 2030. Next, please.
Yeah, and there's a challenge to achieve the balance between performance, appearance, and circularity. To achieve the requested performance and appearance, like high body flex, hydrolyzer stability, good elasticity, washing and cleaning fastness, high abrasion resistance, and of course comfort, based on a 3D printing process, in combination with recycled polyester and a partly bio-based polyurethane, it was needed to work with selected partners to achieve this goal. On the next slides, we will show you how to manage this challenge. Yeah. So I will give you a short introduction about our InSkin portfolio. Thomas, can you? Yes, thanks a lot. InSkin is an umbrella brand Covestro created in 2040 to serve global textile industry. The meaning of the brand suggests inspiration in every square inch. And the aspiration of InSkin is dedicated in improving textile products, critical qualities by applying more sustainable InSkin waterborne PU technology. Why use InSkin PU on textiles? The reason we defined it as an umbrella brand is because of its wide portfolio and performance PUDs and technologies behind. These performance PUDs enable our customers to make very advanced textile goods with premium quality regarding properties, functions, appearance, hand feel, and the more sustainable way of production. The portfolio includes water-based PUDs, partly bio-based PUDs, and also partly biodegradable PUDs. Next slide, please, Thomas. Thanks. We offer with InSkin more environmentally friendly PUD products. We want to be fully circular is not only a statement what Covestro write down on the webpage. We are already working several years on and with partly bio-based PUDs and partly biodegradable PUDs. Those products are already included to our product portfolio and are already in use by manufacturers to help producing coated fabric in a more sustainable way. We offer a wide range of high-quality polyurethane dispersions for textile applications and continuously invest in products and in applications developed such as textile coatings, textile printings, and PU synthetics. For example, in our partly bio-based PUD range, we have products with a content of renewable resources up to 56%. This is calculated on renewable carbon measurement. With this high content of renewable resources, it is possible to create new levels of sustainable textiles. Our partly biodegradable Impranil DLN SD was tested for biodegradability according to the CO2 evaluation test. This is the OECD's test standard 301, and it shows a degradation of about 50% in 28 days. And we will continue to work on more sustainable and biodegradable PUDs. Next slide, please. On the next slides, I want to show you some case and application experiences related to the shoe upper printing system with our product portfolio from InSkin. Yes. For the shoe upper printing trials, we had worked out several recipes based on our Impranil ECO DLS/1, which is an aliphatic polyester base on polyurethane with an MVC of 50%. and a bio-based content of nearly 50%. It is a medium soft dispersion with a very good elongation and a good tensile strength of 27 amperes, as well as a high elongation of more than 800%. Impranil Eco DLS/1 has very good compatibility with mostly all additives such as pigments, fillers, and others. For this printing, we had to use a 100% nylon mesh fabric and a 120 mesh printing screen, and print 10 layers with a short intermediate drying by a hot air dryer, and a final drying step at room temperature for 3 days. We could achieve very good body flux resistance of more than 160,000 turns at 23 degrees, and also more than 50,000 turns at -10 degrees. We have also a very good peeling strength of 18 Newton per 3 centimeters. Next slide, please, Thomas. In this slide, you can see a trial. We had mainly a trial where we run on similar products like before, but we had used here in this recipe also the Imprafix EO3025, which is an aliphatic isocyanate, and it enhances the cross-linking effect. As well, we use propandiol and as a leveling agent, and deformer and a rheology improver. This time we had used a 100% polyester mesh fabric, again a 120 mesh screen, and like by the previous trials, we print 10 times. Besides the 72 hours drying at room temperature, we do also a forced drying at 80 degrees for 5 minutes, and also in another trial we run a forced drying by 150 degrees for 3 minutes. As you can see at the picture, that was a transparent printing application, only to show you that we can do also transparent printing with this system. With the including of the crosslink and the forced drying at 150 degrees, we could improve the cold body flux behavior strongly. On the next slide, I will show you a possible way to combine the bio-based POD with the standard waterborne POD. This is a shoe upper recipe with a 30% bio-based content. We had run these trials with a recipe, what was a combination of the bio-based material and a standard POD material. We had used again the Impranil Eco DLS/1 with the Impranil DL1068, which is a polyester-based POD with nearly 50% MBC. Like before, we had used as our Imprafix EO3025, again with propandiol and some matting agents, leveling agents, rheology modifier, and also dye stuff. The printing was done on a black polyester mesh with a 120 mesh screen, and like before, also again with 10 times printing. And as we do again different kind of drying temperature steps. As we could observe by the results, the peeling strength did not really improve by using higher temperatures, but the cold body flux did improve a lot. So finally, we could arrive to a peeling strength of more than 100 Newton per 3 centimeters and a body flux of more than 200,000 turns at 23 degrees. And also at -10 degrees, we can got a body flux of more than 150,000 turns. We could get already very good results by using these recipes, based only on bio-based POD, but even could increase the performance when we use a combination of a standard waterborne system with a bio-based system. On the next slide, I will give you a short idea how we do that in the laboratory. As we do not have a standard printing equipment like you found in the factories, we need to run the trials manual in the laboratory. Therefore, we use a different type of screens with different patterns, depend on the application, of course. In this case, we use a shoe upper screen with a 100 mesh screen. After we had mixed the printing paste and adjusted the rheology, we do the base layer, print at least 2 times. We make then a drying with a hair dryer, shortly 10 seconds after each printing. And then we could directly apply the top layer again by pre-drying with the hair dryer between each printing. Then we let the system dry for 72 hours at room temperature before we do then the final drying at 150 degrees for 3 minutes. We do run also trials where we do after the printing a direct force drying without waiting for 3 days, and we can achieve very similar results like with the 3 days drying. Now I'd like to hand over back to Thomas so that he can give you some more information about the HUAFENG haptic system.
Yeah, thank you. And as Thomas Beck has explained, that this was the development of the resins and the basic formulation of the coating in lab scale. Now, I would like to give you an overview about what we are doing in industrial application on the 3D fabric coating, and we call it haptic. Haptic is our brand name, our B2B brand. And the haptic technology is basically a new additive manufacturing technology for textile surface finishing. And this is how we do it in production. This is a little video. I can switch it on for you. So this is an automatic screen printing process where the screens are moving along a long table. And the ink, in this case, the base coat is applied directly onto the mesh. And it's an advanced screen printing technology because our screens are able to deposit very high coating thickness. Already with every shot we print, we can deposit a very thick layer. And I continue. And this ink formulation actually, like Covestro already has shown, is a chemically cross-linked polymer. So we use chemical hardeners to cross-link the resin structures, and this results in a very strong and durable coating. And we can also achieve a maximum bonding strength to various types of textile fibers. Basically, it is all based on polyurethane chemistry. And the advantages of haptic are definitely also about sustainability, because we apply the ink, the material we want to add on the shoe surface, we apply directly without cutting any material. So the ink can be nearly consumed up to 100%. So we have no cutting waste during the manufacturing process, no cutting waste of different materials like the TPU films sometimes used. And we end up with very high material efficiency. And what is very important, we work with fully water-based chemistry. And this is really, for many visitors who come to our factory, a big surprise when you walk into the print shop and they look around and they see so many printing tables and so many printing operations going on, but there's no smell. It is fully water-based, and this is a great advantage for our workers for a safe working environment. It is a great advantage for environment that we have no emissions, and it is also a great advantage for fire safety inside the factory. Yeah, and the haptic features and benefits, this is what counts for a consumer basically. We can look at 3 different areas: the visual performance, the visual appearance, the touch performance, and the mechanical performance. And all 3 categories we can modify, we can play around, and I call it, this is a playground of haptics: the visual, the touch, and the performance. And the touch is actually the name-giving word for haptic. Haptic is a kind of scientific word, and it means the touch perception. When you touch something, you feel something, and this is the haptic perception. And the haptic coating is an additive application process. So that means we print many layers on top of each other. You can think about like nature is doing it in a sedimentation process on the ground of the sea, or you can find these kind of rock structures in nature where you see layer by layer, it is material is added on top of each other. And you can also have different types of levels, different types of areas covered. But overall, there is no cutting waste, and this really gives us the high material efficiency. And the coating thickness for shoes, usually we use between 0.2 and 1.2 millimeter coating thickness. And just because of the coating thickness, we can also achieve a special touch performance. So additional to the touch of the textiles, we can add 3D coatings, which you can very clearly feel when you touch the material. Yeah, then let me run through some areas of visual appearance where I want to point out for you. This is just a selection of some typical things, but we can have many more effects. First, the fully covered areas. Haptic can be used to cover some textile areas totally. That is usually used for the toe cup area where you need high abrasion and a very good strong durability, where you also want to protect the sensitive mesh materials. And maybe also on the heel area on this shoe, you can see a fully covered haptic area. So this is the areas where we want support for the feet and protection for the textile materials. So we achieve maximum durability, wear resistance, and support areas. Also functional areas. But we are not limited to fully covered areas. We can also print very fine lines or very fine dots, and the bonding even of these very small dots is very, very strong, as also they cannot be scratched off. And these fine lines and fine dots fully guarantee the breathability of the textile material. So the textile is nearly as breathable as without coating, but still you can achieve a very good protection of the mesh material by these lines and dots. And in addition, you can create very nice visual effects. Gloss is also one area we can play around, and we can make anything between very high glossy areas or very matte surfaces and anything in between. And you can also combine high gloss area and matte areas like you can see on this picture, just staying with the same color range, but just combining different gloss ranges can also lead to very nice, elegant designs. The haptic coatings can also be used to cover sewing lines on materials. For example, what we see on the left side, two different types of fabrics are connected by a zigzag sewing line. And this zigzag sewing line can be overcoated with haptic. What you can see in the middle of the picture on the fat white line. Underneath there is the zigzag sewing line, and it's totally covered and not visible anymore. This can be done in a way to cover it and to make it a kind of surprise how these materials are connected. But it can also be semi-transparent, and this is actually the next effect I want to introduce. It can be semi-transparent that you can see through, and you can see through the sewing line, or you can see through to the mesh background, and you can see the knitted structure of the fabric material. You can also combine semi-glossy and semi-transparent effects, and different colors of semi-transparency can be combined and can be printed on top of each other, creating a third or fourth color. So semi-transparent is a very nice tool of creating very layered designs and very trendy look-through effects. Another exciting color effect is the living color. We call it living color. This is basically, these are two colors printed on top of each other. The base coat, which usually gives contributes most of the thickness of the coating. We put usually a very bright color pigment like the magenta or a bright green, and then on the top the surface color coat, we put usually a darker color, and then when you move these materials, then depending on the viewing angle you look at, this second color on the base coat will pop up, and it looks like the color is permanently changing during movement. And then for sure, we can also do all the metallic effects you can think about. So a golden color, silver color, matte or glossy. The matte we call anodized effects because they look like anodized aluminum. And we have lots of special effects like these iridescent effects, color shifting effects depending on viewing angle, sparkling effects, and whatever you can imagine on color effects. So there's nearly no limitation on color. Then let's come to the touch area. Touch is a name-giving haptic feature. And from touch, we can basically do anything from very soft nubuck-like touch effects to very rough sandpaper-like effects. And these effects are developed by special formulations, but special ingredients we formulate into the ink. And for the sandpaper, for the rough sandpaper effects, actually, you could also think about adding some recycling materials for creating these kind of rough structures. So recycling materials could additionally contribute to sustainability, or we could also think about adding biomaterials to creating these kind of very rough effects. And then about performance, I would like to point out especially the abrasion resistance of haptic. This is a very durable surface haptic, and we even have a very special ceramic. We have special ceramic additives we add into the formulation to achieve an even higher abrasion resistance. And this is just one very specific feature of haptic. We do a lot of data-driven durability testing in our lab, and this is the belly flex method, where should be a little video here. The belly flex testing, where you see we simulate the walking performance of a shoe, and we do that for at least 100,000 times, and then the coating is very carefully examined and observed and checked if there's any cracks happening. So usually haptic performs very, very well, and even in cold temperatures, like Thomas Beek has shown you already, we can do belly flex for up to 100,000 cycles. And then finally, I would also like to show you some international awards we got recently. So the first one I would like to show is the ISPO Tech Trends Award for 22-23. We got the best product ISPO award. Then in 2018 already, we won the IET Innovation Award in London. Actually, this is a award mainly about manufacturing technology and about this automated 3D layer printing. And so Smart Manufacturing Award. And on the right side, you can see the DIA Award. DIA is a International Design Award, a very high-ranking design award provided in Hangzhou in China. So it's a Chinese award, but for the international community, something playing on a similar level like the Red Dot Awards. Yeah, and with this slide, I would like to finish my presentation on haptic and hand over to Bonnie for the Cyclone.
Thank you, Dr. Thomas. Now I will introduce Cyclone Recycle Yarn. Cyclone is our registered brand mark for our recycled yarn. Next, please. With the mission of recycling makes life better, Cyclone dedicates to recycle the waste and made into renewed material. Next, please. I will talk about our company, our technology, and our product. Next, please. Cyclone is the recycled polyester fiber producer. Producer features in high quality, differentiation, and functionality with more than 2,000 employees. Our diverse product includes recycled polyester filament, recycled dot dye yarn, recycled composite yarn, and recycled functional yarn, etc. Next, please. And we have two industry zones, occupies 860,000 square meters. And this is the process of our premium physical recycling. As a vertical supply chain, Cyclone will set up waste bottle collection stations in China. Bottles are cleaned and chopped into flake by the high-end machine introduced from Europe. Through the eco-friendly machines, we make out the PET chips and make out the FDY, DTY with the color and also with function. Next, please. Based on third-party life cycle assessment report, Cyclone Recycle Yarn reduces 75% of their water consumption, 55% greenhouse effect, and 73% cumulative energy consumption comparing with the virgin yarn. You can see each kilogram of the recycled yarn reduced 4.3 kilograms of the CO2. So with capacity of 240,000 tons in 2022, we can recycle 12 billion waste bottles and reduce 394,000 tons of the CO2 emission. Next, please. Cyclone provides diverse products, including the dye yarn and the functional yarn. Dye yarn is the yarn extruded with color, so no need further fabric dyeing. It's also a very environmental friendly product. Next, please. Engineered stretch yarn and the cotton feel-like yarn provides the new vitality on the recycled yarn. The functional yarn also approves longer lasting effect on fabric, like the moisture wicking, anti-UV, and antibacterial, flame retardant. Next, please. All of our recycled products are with the brand required GIS and Architects certificate. Okay, now I will hand over to next.
Yes, I take over here, and yeah, this value chain collaboration we did within this project, the resin, the haptic ink, the haptic printing process, and the recycled yarn really delivers a drop-in solution with lower carbon footprint. And that's why we are moving this idea forward with that co-branding initiative between HUAFENG and the haptic team, with the Covestro incl products and with Cyclone. And at the end, we calculated the CO2 savings for one pair of shoe is about 230 grams per pair, which is, in our opinion, a significant contribution. When you look into more detail, you find out that out of these 230 grams, about 170 grams of CO2 savings come from the recycled PET mesh, and about 60 grams come from the haptic partly bio-based printing ink. So the summary of our project here is really a significant lower CO2 footprint. And this is the result of our project. There's a short video about the final shoe we achieved. You can see the semi-transparent effects. You can see the iridescent flip-flop effects, fine lines and fully covered areas, and recycled mesh based on Cyclone yarn. A great cooperation project where we really feel through partnership we achieved something much better than everybody of us alone could do. Bonnie?
Well, yeah. Well, the technology cooperation module of HUAFENG, Cyclone, and Covestro is really inspiring. Maybe there's more circular printing technology for the future, automotive interior, or some other field. We hope more companies engage in cross-industry cooperation, working together to reduce carbon emission and endeavor to better global sustainability.
Yes, as we understand, the footwear industry is seeking alternative solutions to produce shoes with a lower carbon footprint. And with equal or even better performance, value chain collaboration between Cyclone, Covestro, and HUAFENG is established to address this challenge. And a drop-in solution as developed that can save approximately 230 grams CO2 per pair of shoes is a good point. So we need your participation to create it together and introduce it to our consumers. We are highly looking forward to working with you. So I guess, Thomas, the next page, yes. Yeah, thanks a lot to you all for your attention and interest in our joint presentation. On this page, you can see our contact details about the emails. And I guess we are now ready for the question and answer session.
That's brilliant. Thank you very much, everyone. Just a quick reminder to the attendees, if you have any questions, please submit them to the Q&A box instead of the chat box, and we'll be able to go through them for you. So the first question is, can InSquin handle accidental fire, especially due to electric spark?
So we speak about electric spark. Yeah, okay. It is not only a point of InSquin. Of course, you can use some additives inside to, let's say, to reduce the flammability of a product in general in the coating. Electric spark. I guess we have some measurements what we can test here. Thomas, maybe you have already some ingredients in use. Usually we use only flame retardants inside. To reduce the electrostatic effect.
Yes, there is some anti-static treatment available. So if needed, I mean, it is more used for safety shoes and something like that. For athletic footwear, usually anti-static is not a big topic, but for sure we could think about it.
Yeah, you're right. For worker shoes and so on, that is more used to use this anti-static effects. Yeah.
Brilliant, thank you. The next one's a bit of a long one, so bear with me on this one. The best description of the circular economy refers to keeping the original product going for as long as possible. Thus, it follows that the best looping to use is to repair it. Recycling fibers is something that happens at the end of the product life. I think it is on 9 on the scale of which loops to use, which is only above biodegradability of the fibers in LCA terms. How come the thrust of this webinar has been more about 9 and 10 as opposed to the better strategies for a circular economy? Can the panel comment more about the early stages of the CE loop, revitalizing, reconditioning, repair, reduce, reappropriate, and so on, and how does it apply to these shoes, please?
Would you start, Thomas, from Bonnie, from the point of the fiber?
Yeah, I mean it's a complex question and a very multi-layer question. I mean, the circular economy, yes, ideally it would be a totally circular technology where you can reuse your products and make new products out of it again. What we are doing here at the moment is we are using the PET bottles and clean them and make a yarn, and with the recycling yarn we make new products, not bottles again, but fabrics and shoes. And this definitely contributes a lot already compared to virgin polyesters used for fabrics. But for sure, for the full circular economy, we need something more, and we are moving into this direction. We also develop chemical recycling processes. We develop shoe recycling processes, where finally we also want to come to a more and more circular economy. But we have to go step by step, and I think this is a very nice first step, and we are hopeful that some more will come over the next month and years.
Brilliant, thank you very much. Next question, how does InSquin rate on the ASTMs for decomposition 6691 plus 5511, which also measure the toxicity of biomass remaining?
Okay, the party bio-based PU printing on the top is currently not a chemical degradable point. We have some studies, and there are some studies ongoing exactly in this direction. There are some European and I guess some American companies who use this kind of chemolysers, and that is an enzyme, something in this direction, and they are making an analysis and a study about that. So, but we have not yet finally all the results on hand. Yeah.
That's great. Thank you very much. Can we use this incl product also on natural fiber or leather?
Absolutely. So this impregnated types, or let's say it's general waterborne PUD types, you can use on any kind of fiber so far. So we have also worked out some trials on Kevlar and Nomex. All natural and synthetic fibers working, yes.
Brilliant, thank you. Next question. Can haptic handle sharp touches and not get worn out, as in abrasion resistance?
Sorry, I did not get this question in full meaning.
Sorry.
Could you repeat this?
Of course. Can haptic handle sharp touches and not get worn out, as in abrasion resistance?
I don't get the first part of the question, but haptic is very abrasion resistant. We can easily pass all the footwear standards for abrasion resistance with a normal haptic formulation. And in addition, we have we call it haptic diamond, a special haptic formulation, including very hard ceramic particles and oriented in a kind of diamond shape. These haptic diamond surfaces can achieve 3 to 4 times more abrasion resistance than the standard haptic. So we are one of the best performing surface coating of textiles.
Brilliant, thank you. Next question, can haptic handle fire by flame retardancy?
Sorry, I cannot understand, please again.
Can haptic handle fire by flame retardancy?
Handle fire by flame retardancy. Well, to be honest, haptic so far is not formulated for flame retardancy and for a special. We never did a fire test on a haptic product. Theoretically, yes, we know about flame retardant additives for coatings. We could formulate flame retardant coating formulation. The question is, where do we really need it, and what kind of requirement is really needed? Because we print it on fabric, on polyester mesh or nylon mesh, which is also not flame retardant. So it needs to be a full package of a shoe, a flame retardant shoe, including some additional haptic flame retardant function. But it is not totally out of thinking. But we would need to talk about a development project and the clear specification what is required.
Yeah, from my side, from the PU, yes, you can add flame retardants inside. Of course, you have to prove if that is working together with the polyurethane dispersion itself. But generally, you can apply flame retardancy products to this kind of coatings. We do that already. Yeah. If there's more information needed, please get in contact.
Excellent. Thank you very much. Another question. We would be interested in bio-based PU. How do we get that in India?
So get in contact with me and I will give you the contact details from the colleagues in India. No problem.
Brilliant. Thank you. Next question. Excuse my pronunciation on these. As Velolus or Vio Sucosi is 100% biodegradable. Can you make use of the same?
I guess we speak here about cellulose fiber, and I'm not wrong.
Yes,
so
cellulose.
Viscose or cellulose, yeah.
Yes, viscose or cellulose are basically based on natural wood materials as a raw material, and they are biodegradable, but often also kind of treated, dyed, treated with different chemicals to make it perform. What we do with haptic is actually we use some cellulosic fibers to formulate them into the haptic coating, also to add more bio content, also to use the function of the cellulosic fibers to modify the haptic performance. So this can be done to a certain percentage.
Excellent. Thank you very much. Apologies for that. There was a change to the spelling previously, which I missed. Next question. What does biodegradable PUD break into the water? Does it break down to microplastics?
That's a good point. So it's a good discussion about microplastics. Yeah. So what is microplastics here? We have some studies and some statements, and it's a long discussion, I guess. So it would be the best if we can have later on a call about that or a short discussion by email. But I like to share this information then with you. Yeah. So we have some studies here already. Yeah. But I have not yet on hand what is the real answer on that. Sorry.
Yes, I agree. This is a very big topic and for sure a very important topic we have to face. From my point of view now, I would say yes. I mean, in the PUD, in the liquid water-based PUD, you have very small particles of polyurethane, but during the ink formulation and then during the printing process, the ink will dry and these small particles will agglomerate and stick together. And then we add the hardener and we fuse them by chemical reaction together. So the final haptic coating is not a microplastic. It is a macroplastic with a certain thickness up to 1.2 millimeter and a certain dimension. So this one is definitely not a microplastic, and it will not just disintegrate into very fine microplastic particles. So even when you wear the shoe, it will not disintegrate into fine particles. But for sure, I mean, if you have abrasion, if you rub off the haptic, then yes, there will be plastic particles created and they will be released. But on the other hand, polyurethane is also a material which is not stable forever, so it will show some biodegradation.
That's great. Thank you very much. Next question. My industry is developing a special environmental friendly product. How do I contact this partnership via WhatsApp or mobile number?
I guess on the best per email at first. So as you can see the email addresses in the slide before, so you get in contact with us and we will reply.
That's great. Thank you. Is it possible to have the slide up that does have the contact details on, just so this?
Yes, I can. Here you can see the email
Perfect.
addresses. You are very welcome to send an email directly to us and we will process it.
Yeah.
That's great. Thank you very much. Next question. How do the lifetime stability and durability of the recycled PET fibers compare with virgin PET fibers and yarns? Does the chemical recycling generate virgin monomers to make yarn cause reduction of the strength relative to virgin polyester monomer?
Well, I think I can answer this question.
Yes, please, Bonnie.
As for the recycled PET fibers, there are two technologies. One is physical recycling. The feedstock is the waste bottle. The other is chemical recycling. The feedstock is waste textile. Cyclone's physical recycling, the physical property is nearly the same as the virgin yarn. We've done lots of the production and do lots of testing. The physical property is nearly the same as the virgin yarn. And for the chemical recycling, the feedstock is the with textile. So according to its chemical technology, the strength, also physical property is the same, totally the same as the virgin polyester, because its technology is the depolymerized and through some process and polymerized again. So it will not affect the strength or any other physical property.
That's great. Thank you very much. And next question, two questions for this one. Is the incl bio-based PU recyclable? And is the biodegradable PU only by water? Will this potentially limit the application? Can it be made biodegradable by other means than water?
Mm-hmm. Okay, recyclability of a PU. There are also some work done in this direction. So and here in this case, we speak about a combination of coating with fiber. So in this case, the fiber is a different sort than the coating. So we have a coating, the PU dispersion on the top, and the fiber is in PT. So in this case, recyclability is already a challenge, let's say, yeah. So to separate the different materials from each other. There is a study, as I mentioned already before, between some European companies to make some PU chemolysers. In this study, they use different kind of methods, try to recycle or to reuse the material, let's say. And the other one was a biodegradable PU only by water. Here it is similar because you can use, instead of water, you can use here also we hope that you can use some enzymes in the near future to reuse the material, recycle the material, or biodegradable the material. Yeah.
That's great. Thank you very much. Next question is the yarn compatible with latex fabric or other spandex fabric?
Yes. The polyester fiber is compatible with the other fiber into knitting or weaving into the fabric. For example, can be composite with cotton, with spandex, with nylon, etc.
That's great. Thank you very much. What's the average amount of oligomers in recycled polyester?
Oh, this question is really professional. I think I can reply later.
Okay.
Maybe I can say a little bit. As far as I know, the Cyclone, and we are working closely together with Cyclone. They are working with very sophisticated machine technology, and during the extrusion process, during the melting of the polyester bottle flakes, actually there is a special process to take out the oligomers. So the resulting PET will perform nearly like a virgin PET, because they have a process to take out all the oligomers. So what the final remains of oligomer is, I also have no number. Maybe Polly can find out, but it should not be a lot, because the IV, the viscosity, internal viscosity, is basically matching with a virgin polyester.
That's great. Thank you very much. Next question is, hi, is there any test method to identify, analysis, recycle, and virgin PU?
As far as I know, there are some ways to handle this with the C14 study, when I'm not wrong. I have not a clue about which real method it is, but I can check it out with our R&D guys.
There is some marking system available. So yeah, some companies put markers into the recycled polyester yarn, and then these markers can be clearly identified in the final product.
Yeah. But
this is one way to do it. But
this question was with the PU and if recycled or non-recycled PU. So first of all, I guess it is already mentioned, the recycling of PU is not so easy. Yeah, maybe that is here to trigger if there's misleading information on the material, maybe, yeah, so that you can check it easily if it is recycled or not. Yeah, but you're right. With some markers, you can check it out. But that these markers you have to put to the stage of polymerization already, when I'm not wrong.
Yes. Yeah. And on the other side, the marker only works one time, one cyclist. If you go for circular economy and want to recycle it again and again, then the marker will also get mixed up. So
yeah.
That's great, thank you. And I believe this might be the last question for the session, unless any more are brought in. But will Insquin be compatible with copper coating?
Yes, copper coating. Copper, like the metal?
Yes.
Yeah, I have some experience with some, let's say, special pigments, or let's say special fillers, which you have some metal effect or the aluminium effects and so on. There was also copper inside, so I did not saw any issue here until you don't use, let's say, a material that have a high content on the solvent inside. And as I know, Thomas, you already use also some metal, let's say, complex for this kind of shiny coatings. So when I'm not wrong, you even work with similar system like the copper coatings. Huh?
Yes, yes. I mean, we usually use pigment, and there are also a lot of aluminum pigments which can be used. If this is the question about metal. But the coating formulations we use, they're really made for textiles, and they're optimized for flexibility, for good bonding on textile fibers. So bonding on metal, I think, will not be perfect.
Yeah.
But there are other polyurethane coatings available for
of course,
metal
of course. Yeah. So when you speak about metal coating, that is it's a little bit different story to that.
Yes.
What we do here so far. But okay, the person can send an email and we can go in details about it, I guess.
That's brilliant. Thank you very much. I believe that concludes our Q&A session for this webinar. Thank you everyone for attending. And thank you to our panelists. Again, I'll just mention that we will be sending an email out with a recording of this webinar for our website, so you'll be able to view it there. Thank you, everyone.
Thank you to everyone.
Okay. Thanks for joining, everybody.
Goodbye.
Bye-bye.
Bye-bye.